Alright, welcome back everybody. In this video we're going to look at the last two examples from the connecting f prime and f double prime with the graph of f lesson. So let's go ahead and get on to it. Example 3, we're supposed to identify where the extreme values of the function occur and use the second derivative test to determine if they are maxima or minima. So hopefully you've read about the second derivative test a little bit, and essentially, it says that when we have a critical point where f prime is 0, that we can look at the second derivative to decide if it's a maximum or a minimum. And I'll scroll up here for a second. If we know that the derivative is 0 and the second derivative is negative, then we know that the curve has an extreme value here because of the critical point, and that when it's less than 0, the graph is going to be concave down, which means since it's concave down and we have an extreme value, that value has to be a maximum, and vice versa for minimums. So let's go ahead and do this. We'll identify where these values occur, and we'll use the second derivative test to decide if they're maxima and minima. So we go ahead and find the first derivative. It's y prime equals 3x squared minus 6x plus 1. And then we're going to use the second derivative test, so I'm going to go ahead and find the second derivative a while. Y equals 6x minus 6. Okay, now I need to find out where the first derivative is equal to 0. And I could go ahead and use the quadratic formula for this, or if I'm lazy and I have a calculator handy, I can go ahead and solve this equation on my calculator. So we'll go ahead and punch up that first derivative, and we will find the zeros of that first derivative. And so I can go ahead and use my zero command, and we find that the first one happens at 0.184. Okay, and the second one happens at 1.816. Okay, now, using the second derivative test, I'm just going to go ahead and substitute these values in. So y prime at, was that negative 0.184? No, that was a positive 0.184. At x equals 0.184 is 6 times 0.184 minus 6. I'm not even going to find a value for this. I just can tell from this that it's going to be a negative. And y double prime at x equals 1.816 is going to be a positive. And therefore, from the second derivative test, we have a maximum where the derivative is 0 and the graph is concave down. So we have a maximum at 0.184, whatever the y coordinate of that is. And we have a minimum at 1.816, whatever the y coordinate of that is. And now we'll go ahead and find those y coordinates. Again, I'm going to kind of cheat here from a time perspective and use my ask function on my table. And I'll put 0.184 in. We get negative 1.911. And I'll put 1.816 in. We get negative 4.089. I did something bad here that I would advise against you doing. I would advise against you using these rounded values when you're finding the y coordinates. It would be better if we had kept more decimal places of accuracy in order to find the... Did I just say y values? In order to find the y values of these points, it would be recommended for us to keep more digits of accuracy in these, just in case. It's possible that it might change our rounded value of the y coordinate by, 100th or 2, if we don't have enough decimal places of accuracy in our x coordinates. All right, but I'm not going to go back and fix my little error that I made there. That's just a recommendation for you for future reference. All right, example 4. Find the following information about the function y equals 1/12 x to the 4th plus x to the 3rd minus 8x squared plus 7x minus 12. So we want to find the maxima and minima, the intervals of increasing, decreasing, the points of inflection, and the intervals of concave up, concave down. So this is really tying all the information from this lesson together into one problem. First, I need to find where y prime is equal to 0 and where y double prime is equal to 0. Y prime is 1/3 x to the 3rd plus 3x squared minus 16x plus 7, and y double prime is x squared plus 6x minus 16. Okay, so to find the points of inflection, we're going to set y double prime equal to 0 and solve for x. This is easy enough. This is factorable. And so we have points of inflection at 2 comma something and -8 comma something. And we just will need to figure out the y coordinates of those. And for the intervals of concave up, concave down, I'm going to make a sign chart of y double prime. And it's easy enough for me to substitute 0 back into this expression and figure out that it is negative there. If I substitute 3 in, it's positive there. And if I substitute -10 in for this last interval, that's positive there. So my intervals of concave up and concave down, it's going to be concave up for -infinity to -8 and 2 to infinity. It's going to be concave down for -8 to 2. And all I need yet is the y coordinates for the original function. We'll hold off on that for a minute. Alright, next I need to figure out where y prime is equal to 0. So I set my first derivative equal to 0, and I'm going to go ahead and use my calculator on this one to find these zeros. 1/3 x to the 3rd plus 3x squared minus 16x plus 7. I should have 3 zeros for this. Do I see them all? I only see 2. So let me fan my window out here a little bit. Now I see all 3. Alright. Now I want to find the zeros. Put my left bound over at -19, because I know that's going to be to the left of this first 0. And let's get to the right. There we go. So we've got -12.860 or -12.85961. And put that right bound at 2. I get 0.483733, 0.483733. And I'm keeping all those digits just so that I have them for the calculation for the y coordinates later on. And 3.375874, 3.375874. All right, and we'll find all those y coordinates in a moment. But first we're going to do the intervals of increasing and decreasing. And so I'm going to set up a sign chart here. Negative 12.860. Having a devil of a time writing an 8 there. 0.483 and 3.375. Okay, so let's see. When x is 1, this is negative 16, that's 3, that's 1/3, so it's going to be negative there. When x is 0, it's going to be positive. When x is negative 20, it's going to be negative. When x is 5, it's going to be positive. Okay, so it's increasing from negative 12.860 to 0.483, and from 3.375 to infinity. It's decreasing from negative infinity to negative 12.860, and from 0.483 to 3.375. All right, and the last thing I need is the y coordinates of all these points. I'm going to go back and put my original function into here and use my table ask to get all those y coordinates. Come on, x third minus 8x squared plus 7x minus 12. And I'll find them one by one. Negative 12.85961. 0.483733. 3.375874, 2, and negative 8. Alright, now I can go over into this y column to get more decimal places of accuracy. I've got negative 1272.637. And we've got negative 10.368. And we've got negative 30.244. And we've got negative 20.6 repeating. And we've got negative 750.6 repeating. Alright, so there are our points of inflection. Here are our maxima and minima, and realize because of what's going on with the sign chart over here, because of what's going on with the sign chart over here, I know that this first point is a min because the derivative changes sign from negative to positive. I know the second one's a max, and the third one's a min. All because of the sign changes on the orange highlighted sign chart. Alright, that's all we have time for today. See you guys next time, and have a great rest of your day.